Hi students, welcome to my lectures on mechanical unit operations. Hi students, welcome to my lectures on mechanical unit operations. Today we are going to learn how to measure the superficial velocity in a packed bed. The one which is before you is a container filled with a sand, and the bottom is connected to the tap and the top outlet is connected so that I can measure what is the flow rate that is going into this vessel. So I have given certain velocity or certain volumetric flow. You can see the bed, the bubbling bed is start happening. This is called packed bed. It has got many industrial applications in catalysis as well as in filtration applications. You can observe there is water that is coming out of the bed. Then what is the velocity, superficial velocity in such cases? You can see there are two things. One is the velocity here in the bed is different because it has got less space because of the particles. The velocity here, compared to here, the velocity is less here because as there is less space here, the water will move very fast because smaller the area, speed the water will go. Here this is called empty tower. Here the velocity of the water is low compared to the velocity in the bed. So whatever, because it is impractical to measure the velocity in the bed, so we measure the velocity here, which is called superficial velocity. In the industries also people will use this superficial velocity to design different equipments. And how to measure the superficial velocity is very simple. Whatever the flow rate we are pumping divided with the cross sectional area of this particular empty tower. So the volumetric flow rate divided this cross sectional area of this empty tower will give you the superficial velocity. Okay, and let us see how to measure the superficial velocity. I have kept some measuring cylinder over here. I will measure for some time the flow for some time. Okay, I have let me take the outlet. Okay, this is the outlet. Now I am putting the outlet here. I will start my timer. Okay, let us measure. As you can see, I started measuring using measuring cylinder. I have measured it for 10 seconds. Okay, now I have measured at least 50 ml, okay, in the 10 seconds. So the volumetric flow rate will be this 50 ml divided by 10 seconds. Okay, that is what my volumetric flow rate. Let us go to the board and measure the superficial velocity as well as the velocity inside the bed. Okay, and let us measure the velocity, the superficial velocity here, and then we also predict what will be the velocity inside the bed using some correlations. So this is what we are going to do on the board. And dear students, this is what our schematic looks like. There is a container which is filled with the sand particles. I have given inlet water at the bottom, the outlet to the water at the top, and this is the measuring cylinder where I have collected V amount of volume in the time t. And the velocity, as I told you, the superficial velocity is velocity in this empty tower is called the superficial velocity. The velocity inside the bed is different. The velocity in the empty tower is different because as you can see there are very small spaces that are available for the water to flow. As you know, the moment you reduce the area, the velocity will be very higher. So the velocity inside the bed is very much high compared to the velocity in the empty tower. Of course, the volumetric flow rate is same in both the beds. Here location, this location, the volumetric flow rate is the same, but the velocity varies. What is the area? Because I have taken the cross sectional area of this particular empty tower is 3.5 centimeters. Now I know pi d square by 4, 9.62 centimeter square. And what is the Q? Which is volumetric flow rate, which is V by T. Okay, volume that is collected divided by time of collection, as we have measured 50 ml in 10 seconds. That if you put the numbers here, that is ml per seconds. So V naught is the superficial velocity, which is volumetric flow rate divided by empty tower cross sectional area, Q by A. V is volume, how much amount of volume I have collected? 50 ml. The time which I have collected, it's for 10 seconds. Okay, the area is 9.62. So if you put the numbers over here, give me some time, I'll calculate. Okay, once you know the superficial velocity, the velocity in the bed is given by superficial velocity divided by porosity of the bed. So depending upon the porous spaces inside the bed, the velocity will be dependent. So the superficial velocity divided by porosity will be the velocity in this bed. Okay, we will calculate both the quantities now. So I have measured V is equal to 50 ml, T time equal to 10 seconds, and area is about 9.62. My velocity is nothing but the flow rate divided by area, V by T by A, which is 0.51 centimeter per second. And the velocity in the bed is given by whatever the velocity, the empty tower velocity divided by porosity. Typically in industry, the porosity lies between 0.4, 1.3, in that range. Okay, if I take a number 0.3 as a porosity of my bed, then V is equal to 0.51 divided by 0.3, 1.73 centimeter per second. You can see always the velocity in the bed is higher than the velocity in the empty tower. Because of this, less area available for the flow in the packed bed. I hope now you understand how to measure superficial velocity in real. Thank you very much.